1. Hayama Natural Science Research Institute. Wrong scaling of speed of light and time separately. August 8, 2020. Here, the reason why the mistake in handling time and speed of light separately lies in the Lorentz transformation will be explained. 1. Why the speed of light is constant. 2. Lorenz's mistake. 3. Einstein's mistake. 4. The speed of light in the vacuum of the same inertial system is constant. 5. Change in speed of light between different inertial systems. 6. Velocity synthesis when observer moves. 7. What is Lorentz transformation? 1. The reason why the speed of light is constant. In the wave phenomenon, if the period is Ts, the frequency f, hz of the wave is defined as follows. F equals 1t, hz, 1. If we change this period, t, to wavelength, it becomes light velocity, c, in vacuum. F equals c hz, 2. The fact that this time scale, 1, changes means that c also changes. This is self-evident, whether it is a light clock, c, or a table clock, 1, which is still a clock. Therefore, changing time, 1, has the same meaning as changing the speed of light, c, and the ratio is constant. 2. Lorenz's mistake. Following Michelson-Morley's experiment, Lorentz considered Lorentz contraction in which the ruler contracts in the direction of travel as a reason why the composition of c plus or minus v speed of light and velocity of motion does not become Galilean transformation in the absolute stationary coordinate system. Vysotsky, own work, CCBYSA 4.0, link. Here he makes a big mistake. If the changes in time and speed of light are the same, the way the clock progresses is unchanged, absolute time, and only the ruler does not change. Therefore, when it changes from Galilean transformation to Lorentz transformation, it is wrong. 3. Einstein's mistake. Einstein's theory of relativity states that, contrary to Lorentz, the speed of light is invariant, c, and the time, t, changes, tau. Ct squared, x squared, y squared, z squared, c, speed of light, t, time for the observer, x, y, z spatial coordinates of the object for the observer, is an invariant quantity with respect to the Lorentz transformation. That is, this value will be the same no matter what coordinate system the object is observed in. Therefore, if tau equals indefinite integral d, and tau are defined as d, c squared equals d, ct squared, dx squared, dy squared, dz squared, this tau is also an invariant. This tau is eigentime. For the coordinate transformation, Lorentz transformation is adopted for some reason. I changed the Galilean transformation to the Lorentz transformation, which is also wrong. Moreover, Lorenz accepts that it is correct that Einstein's time changes, and that Lorentz transformations change time. Einstein assumes that the speed of light is invariant, but the speed of light between inertial systems is not constant. Violation of the principle of invariant light speed. If Lorenz is wrong, Einstein is also wrong. 4. The speed of light in the vacuum of the same inertial system is constant. If the free space of electromagnetism is made into the absolute stationary reference frame, the speed of light is the whole area, and the way the clock progresses is the same everywhere. In electromagnetism, free space is a virtual space in which no substance exists. It is defined by physical constants such as the speed of light in vacuum, the magnetic permeability of vacuum, and the dielectric constant of vacuum. If the free space of electromagnetics is made the same inertial system as the observer, the speed of light in the vacuum of the inertial system becomes constant. No scholar would be opposed to making this, the speed of light in a vacuum of the same inertial system, as the observer constant, the reference frame of the speed of light. 5. Change of speed of light between different inertial systems. Galileo and Newton's inertial system does not mean only inertial systems separately, but presupposes a distinction between inertial and non-inertial systems, that is, a mechanical relationship. Without that distinction, there is no distinction between inertial and non-inertial. Therefore, is it that the clocks of moving objects are delayed, rather than accelerating the observer, not each other? Or will it accelerate the target? The sign of how time progresses with respect to exercise also changes. Equivalent principle of reference system of light velocity. 6. Velocity composition, when the observer moves. For the observer of the Earth that revolves in the Michelson-Morley experiment, and the method of velocity synthesis when both the observer and the observed object move. Velocity synthesis for moving observers. 7. What is Lorentz transformation? To explain the results of this experiment, it is assumed that the transformation from the absolute stationary coordinate system is not the Galilean transformation, and the Lorentz transformation, which is a transformation that causes covariance in electromagnetism, was conceived. Furthermore, the theory of special relativity was created from Einstein's principle of special relativity, too, which abolishes the assumption of absolute stationary coordinates, and that the physical law is invariant in all inertial systems transformed by Lorentz transformation. In the Lorentz transformation, the Galilean transformation is an approximation of the relative velocity between the inertial systems with respect to the speed of light, which is minute. The Galilean transformation itself has nothing to do with the concept of absolute stationary coordinate system. Maxwell's equations are also unrelated to the concept of absolute stationary coordinate system. Also Newtonian mechanics. In Newtonian mechanics, since there is no absolute stationary coordinate system in the universe, all velocities are always relative velocities seen by the observer at that time. The Lorentz transformation was considered as the above classical theory is valid only in the absolute stationary reference system. But if classical theory wasn't tied to it, it was useless in the first place. Popular posts from this blog. Law of conservation of momentum of light.